Hello everyone, my name is Samir Ahmad, yes, Department of Mechanical Engineering from Sri Venkateswara College of Engineering. My technical seminar on manufacturing of polypropylene granules. Introduction. What is polypropylene? Polypropylene is a thermoplastic additional layer polymer made from the combination of polypropylene monomers. It is used in a variety of applications to include packaging for consumer products, plastic parts for various industries, including the automotive industry, special devices like living hinges and textiles. Today, it is one of the most common produced plastic in the world. According to some reports, the current global demand for the material generates an annual market of about 80.7 million metric tons, and it is estimated that the demand will be raised to approximately 83.94 million metric tons by 2024. The major end users of the polypropylene are the packaging industries, which consumes about 30% of total, followed by the electric and equipment manufacturing, which uses about 30% each. Household appliance and automotive industries both consumes 10% each, and construction materials follows with 5% of the market. Characteristics of polypropylene: chemical resistance. Diluted bases and acids don't react readily with polypropylene, which makes it a good choice for containers of such liquids, such as cleaning agents, first aid products, and more. Elasticity and toughness. Polypropylenes will act with elasticity over a certain range of deflection, but it will also experience plastic deformation early in the deformation process. So it is generally considered as a tough material. Toughness is an engineering terms which is defined as a material's ability to deform without breaking. Fatigue resistance. Polypropylene retains its shapes after a lot of torsion, bending, and or flexing. This property is especially valuable for making living hinges. Insulation. Polypropylene has a very high resistance to electricity and it is very useful for electronics components. Transmissibility. Although polypropylene can be made transparent, it is normally produced to be natural opaque in color. Polypropylene can be used for applications where some transfer of light is important or where it is of eccentric values. If high transmittivity is desired, then plastic like acrylic or polycarbonate are better choices. Different types of polypropylene. There are two main types of polypropylene available: homopolymer and copolymers. The copolymers are further divided into block copolymers and random copolymers. Each category fits certain applications better than the others. Homopolymers polypropylene is generally purpose grade. You can think of this like the default state of polypropylene materials. Block copolymer polypropylene has copolymer units arranged in blocks and certain anywhere between 5% to 15% ethylene. Ethylene improves certain properties like impact resistance, while other additives enhances the another properties. Copolymer polypropylene has the comonomer units arranged in irregular or random patterns along the polypropylene molecule. They are usually incorporated with anywhere between 1% to 7% in ethylene and are selected for applications where a more malleable, clearer product is desired. Why is polypropylene used so often? Polypropylene is used in the both household and industrial applications. Its unique properties and ability to adapt various fabrication techniques and make it stand out as an invaluable material for a wide range of uses. Another invaluable characteristic is polypropylene's ability to function as both a plastic material and as a fiber. Polypropylene's unique ability to manufacture through different methods and into different applications meant it to soon started to challenge many of the old alternative materials, notably in the packaging, fiber, and injection molding industries. Its growth has been sustained over the years and it remains a major player in the plastic industry worldwide. Production process of polypropylene. In a gas phase polymerization, the propylene is contacted with solid catalyst material intimately dispersed in an agitate bed of dry polymer powder. Two different methods are used to carry out this reaction. In the fluidized bed process, the monomer flows through a perforated distribution plate at the reactor bottom, and rapid gas circulation ensures fluidization and heat removal. Unreacted polymers is separated from the polymer particles at the top of the reactor and recycled. The fluidized bed plant are able to produce a wide range of polymers. A modification uses a second reactor connected in series to perform copolymerization. In the above diagram shows generic polymerization process of polypropylene, and the below diagram shows the polypropylene gas production. These are the images where the production occurs. Liquid phase polymerization. In liquid phase polymerization process, catalyst and polymers particles are suspended in an inert solvent, typically a light or heavy hydrocarbon. Supercritical slurry polymerization process use supercritical propane as dilute. Slurry process run in loop reactors with solvent circulating stirrer tank reactors with a high boiling solvent or a liquid pool in which polymerization takes place in a boiling light solvent. A variety of catalysts can be used in this process. This is the flow diagram of liquid phase production. Advantages of polypropylene. Polypropylene's chemical properties is meant to it does not react with acids, which make it ideal material for containers make, made to hold acidic liquids such as cleaning agents. Polypropylene is also highly resistant to corrosion and chemical leaking, making it the choice material for piping system. Polypropylene will turn into liquid and its melting point, and in this form it can be molded into any desired shape, and this can be done in several times without much degradation to the plastic. Polypropylene is used in the injection molding because of its response to heat. Polypropylene does not conduct electricity well and so is classed as an insulator. This has made it an excellent material for manufacturing to be used with electronic components such as cables and audio equipments. Disadvantages of polypropylene. Polypropylene is often affected by UV degradation, making it is not suitable for use in high altitude or places where UV penetration is high. Polypropylene has limited use in high temperature as it suffers from chain degradation, which can lead to oxidation. This results in cracks appearing in the polypropylene but can be fixed with polymer stabilizers. Polypropylene has poor bonding properties, which make it a hard material to bind. One solution for this is to treat the surface to enhance the adhesive strength of paint and inks which can color the polypropylene. Applications of polypropylene. Packaging application. Good barrier properties, high strength, good surface finish and low cost make polypropylene ideal for several packaging applications. Flexing packaging. PP films excellent optical clarity and low moisture vapor transmission make it suitable for use in food packaging and other market shrink film overwrap. Electronic industries, films and graphic arts applications. Disposal diapers, tabs and closure etc. PP films are used either as cast film or axially oriented PP. Rigid packaging. PP is blow molded to produce crates, bottles, and pots. PP thin walled containers are commonly used in food packaging. Consumer goods. Polypropylene used in several household products and consumer goods applications, including translucent parts and housewares, furniture, appliances, and luggage toys. Automotive applications. Due to its low cost, outstanding mechanical properties, and moldability, polypropylene is used in automotive parts. Main applications included battery cases and trays, bumpers, fenders, liners, interior trims, instrumental panels, and door trims. Other key features of automotive applications of PP include low coefficients of linear thermal expansion and specific gravity, high chemical resistance and good weatherability, processability and impact and stiffness balance. Medical application. Polypropylene is used in various medical applications due to high chemical and bacterial resistance. Also, the medical grade PP exhibits good resistance to steam sterilization. Disposable syringes is the most common medical applications of polypropylene. Other applications include medical vials and diagnostic devices, petri dishes, intravenous bottles, specimens bottles, food trays, pans, pill containers, etc. Industrial applications. Polypropylene sheets are widely used in the industrial sector to produce acidic and chemical tank sheets, pipes, returnable transport packaging, etc. Because of its properties like high tensile strength, resistance to high temperature, and corrosion resistance. Conclusion of polypropylene is polymers are long chain molecules with properties dominated by their chain behavior and the nature of the chemical makeup or constitutions. The distinctions of between the thermoplastic and thermosets has become rather blurred with the development of new material for more demanding environment than previous. They included high performance polymers which are more resistant to the high temperatures, possess a great mobility and or strengths, and can be combined with additives to enhance their intrinsic properties yet further. An understanding of the atomic and molecular construction of the polymers provides an insight into how improved materials can be developed. In the subject of molecular engineering, it includes an understanding of both molecular configuration and conformation. These are the references. Thank you.